Welcome back, my 7th grade advanced class. Let's knock out 8.7. It says write the numbers in scientific notation. To write this in scientific notation, I would take the decimal and move it back 1, 2, 3 places. That would give me 3.8 times 10 to the negative 3 power. Number 3, I'm moving this decimal back 1, 2, 3, 4, 5 places. So that's going to be 4.75 times 10 to the negative 5 power. Remember, we always want the decimal after the first numeral. That's how we know how much to count. Next is to tell whether triangles are similar. Number 5 says that I've got 41 and a right triangle. This one's 53 and a right triangle. To solve this, I'm going to take 180, which is the measure of all angles in a triangle. I'm going to minus 90 for that 90-degree angle here. That's going to leave me 90. I'm going to minus 41. And if these are similar, it will equal 53. But it does not. This is a 9, and this is a 4, and 49 does not equal 53. So these angles are not going to have similar angles. Yeah, the triangles have different angle measures, so they are not similar triangles. Let's move to number 7. Number 7 says find the sum, difference, and product and quotient of the expression, right? Write your answer in scientific notation. So we have number 7 here. We're taking 6 times 10 to the 4th, and 1.5 times 10 to the 4th. This is going to give us, well, we have to multiply 6 and 1.5, that's going to be 9. And this would stay the same. So this is going to be the sum of, so they're asking for all of these. The sum, we'd add 6 and 1.5 to make 7.5. This would stay the same then. The difference, I'd minus this, would be 4.5 times 10 to the 4th power, or negative 4th power. The product is when we multiply, like I said, we're going to have 6 times 1.5, which gives us 9, and then 10 to the negative 4, and 10 to the negative 4, that's going to give 10 to the negative 8. And lastly, find the quotient. This will give me 6 divided by 1.5, which will give us 4. And then we've got negative 4 minus negative 4. That means we're going to have a 0 there for our exponent, which will make this 1. The answer really should have just been 4. Right? But they did say write your answers in scientific notation. So that's why they have 4 times 10 to the 0 power. Let's go to number 9. It says find the sum or difference. Write your answer. This is a difference because it has a negative sign here. If I'm putting these together, I realize that I'm going to have to, let's see, I'm going to have to, I'm going to be taking this from this. And I need to write these out to kind of make sure I'm doing this right. This is going to be 6, 3, 3, and then to the negative 9. So it's going to be going back this way, right? So this is going to be going back 9 places, right? So I'm just going to put my work here. My decimal would be here, and that's going to give me 8 zeros, right? So let's see, this one's going to be 1, 2, 3, 4, 5, 6, 7, 8, and then 6, 3, 3. Then this one is going to be 4.5, and then with 8 zeros, right? So this one's going to be 1, 2, 3, 4, 5, 6, 7, 8. Sorry about that last one. I'm going to make those corrections. Should have been a 0 here and here. And then we'd have 4.5. That will actually just be 45, right? We do this, we realize that we're going to be subtracting these numbers here. So this is going to give us a 3 and an 8 and then a 1, so it'll be 183. Our decimal would have to go here, and then to bring it back there, we'd have to have a -9, right? See if we're doing this right. See, 1.83 times 10 to the -9, all right? Number 11 is we're adding these, so we're going to take these numbers, and this is going to be a little different. You might notice that 7 plus 5 is not going to make 1, but what you might also know is it will make 12. This is how we do this. We're taking 7.2, 10 to the -6 power. So this is going to be going back 5, right? 1, 2, 3, 4, 5. It's going to be 72. And this is going to be going back 5. So the decimals here, 1, 2, 3, 4, 5. And this time it's going to be 5, 4, 4. All right, so when we are adding these, we see that the 4 is going to come down. Let's put the line here. The 6 is going to, 4 and 6, 4 and 2 make 6. And 7 and 5 make 12, right? That's going to carry 1 over here. Then we're going to have 1, 2, 3, 4 zeros, right? Here's the problem with that. Remember, we're to the -5 power. So to bring it back, we're going to have to go 1, 2, 3, 4, 5, and that puts a decimal here. That's why I have 1.264 times 10 to the -5 power. All right, let's move on. Number 13, we're going to work on a different page. I'll show you in a little bit. I want to make sure I can show you these properly. All right, we're starting over here with number 13. Number 13 says 5 times 10 to the -5 power. That's going to put me at 4 zeros, 1, 2, 3, 4. My decimal here with 5 there, right? Because it went back 5, 1, 2, 3, 4, 5. And then this one, which goes back 3. So we're only going to go back 3 with this one. So my decimal is going to have 2 zeros, right? And then it's going to be 246. We're adding these. So this is going to be a 1. Carry the 1. That'll be a 5. That'll be a 2. We have 0, 0. Now to get it back, we're going to be taking that decimal 1, 2, 3 to make it, to put the decimal after the first number. This is going to give us 2.51 times 10 to the, remember we moved it 3, 10, not x. So 2.51 times 10 to the -3 power, okay? Next, we have number 15. We got 2.4 times 10 to the -1. That's just going to bring it back 1. It'll be 0.24. But this one's going back 2. So when I do this one, it's going to be, when I'm lining up my decimal, this is going to be a 0 here, right? Because I'm going back 1, 2. And then the 5 starts with another 5. All right? And now, remember I'm subtracting, so I've got to borrow 1 from here, which turns this to a 3, and 10 minus 5 is 5. I've got to borrow 1 from here, and that's 13 minus 5, which is going to give us 8. And then the 1 comes down with the decimal. And now we bring the decimal over, it's going to be 1.85 times 10 to the 1 power is times 10. Oh, I'm sorry, it did go back 1, so that would be negative 1 power. Sorry about that. I forgot that we did bring it back 1. All right. Number 16 is yours to do. Let's go to number 17 now. Find the product or quotient. This is giving us 5 times 7 times 10 to the 7th power. So we're going to be multiplying 5 times 7 and then multiplying it to 10 to the 7th. I know 5 times 7 is going to be 35. And remember, this 7 had 7 zeros to it, right? So that's 1, 2, 3, 4, 5, 6, 7, right? But we have to keep in mind the decimal is going to end up here. So this is going to be 3.5, and this is going to be to the 1, 2, 3, 4, 5, 6, 7, 8. So times 10 to the 8th power. All right, let's look at 19. We're dividing it by 4 this time. So we're going to be taking 1.2 and dividing it by 4. I know 12 divided by 4 is 3. So this should give us, see, 1.2 divided by 4. I'm going to make sure I got this right. I know it's going to be, I'm almost positive it's going to be 0.3. So 1.2 divided by, let's see, 4. And that's going to give us 0.3. Good. So this would be 0.3, right, is the product of difference of here and here, the quotient of it. And then we're multiplying this. Well, actually, we're going to have negative 5, right? So this has to go back 5 places. So so we're going to be going back 1, 2, 3, 4, 5, right? But remember that goes back to 1 there. So actually, it's just going to be 4. All right. All right. And let's see. When we bring it back over here, I think that's going to put it to the negative 6 power. Yes, because we had 5, negative 5, we'll put it to 5, and then we're going to have to go back 1 decimal will be here, 1, 2, 3, 4, 5, 6. So that would be 3 times 10 to the negative 6 power. All right. To better illustrate that, picture it like this. We've got 1.2 that we are multiplying or dividing by 4, right? And then we have 10 that we're putting to the negative 5, so that's going back 5 places, right? So this is going to give us 0.3, right? And then we go back 5, that's 5 zeros, right? 1, 2, 3, 4, 5. But to bring it back here, we'll have to go 6 places. And that's why it'll be to the negative 6. All right, 21. We've got 3.6 divided by 7.2. All right. Let's solve that. Both of these are 10 to the 7th power. So when I take 3.6 and divide it by 7.2, it gives me 0.5. So since it's going to be 0.5, and then we've got some zeros, 1, 2, 3, 4, 5, 6, 7. Remember, we need to move this decimal over 1, right? And that's going to go ahead and now make it a 5 to the, well, let's see, 1, 2, 3, 4, 5, 6, 7, right? So let's see, we moved it over 1, had 1, 2, 3, 4, 5, 6, 7 zeros. So now that's going to be 1, 2, 3, 4, 5, 6, 7, 8. So this would be times 10 to the 8th power. And, oh wow, I did forget one thing. Okay, this has to be worked a little bit differently than what I put here. And I apologize. I forgot we're dividing. So what this really is going to be is 3.6 times 10 over 7. Okay, that's going to be divided by 7.2 times 10 to the 7, right? So when I get a 7 on the bottom, 7 on the top, this would be 10 to the 0, which is 1, right? This will end up being 0.5, as I said. Is that 5 or, hold on. Yeah, it was 0.5. So this is 0.5 times 1. And if we're moving this back forward, well, that tells me we're going to have our power to, we have to come forward, and that's going to be 10 to the, is that the first power or the negative 1 power? I'm thinking it's going to be the negative 1 power. In fact, I'm positive that it will. So this is going to be 5 times 10 to the negative 1. Yeah, that's right. All right, let's go to 23. This time we've got to multiply. I know 10 to the 8 times 10 to the negative 5 is going to give us 10 to the 3 power, right? Because when we multiply, we add these together, and 8 minus 5 is 3. Let's see, and then we have 6.5 divided by 1.4. 6.5 divided by 1.4 is going to give us, oh, is that right? 6.5, oh, I'm sorry, we're multiplying. 6.5 times 1.4, big difference. That's going to give us 9.1. So we should get 9.1 times 10 to the 3rd power. All right, now we're going to mosey on to number 25. It says, you use technology to find 4 sums, match the sum with the standard form. These are the standard forms, these are the sum. This says 4.e, and it says e, the exponent is 8. So that means I'm going to be moving this forward 8 places. So that's going to be 7 zeros after the 3. Over here, I see after the 3, there's 9 zeros. Over here, I see after the 3, there's 1, 2, 3, 4, 5, 6, 7 0. 25 has to be C. All right, 27 says 4.3 exponent to the 10th power. And that looks like this one, because when we move that, that's going to be 1. And then 3 and 3 and 3 make 9, and 9 plus 1 make 10. So 27 should be D. All right, 29 is next. How many times greater is the thickness of a dime than the thickness of a dollar bill? Well, the thickness of a dime is 0.135. The thickness of a dollar bill is 1.0911 times 10 to the negative 2 power centimeters. So when we're doing this, we're going to divide the thickness of the dime by a dollar bill. We're taking this 0.135 and we're going to divide it by 1.0922 times 10 to the negative 2 power. When I turn this into scientific notation, I'm going to move that decimal 1 over, which means I'm going to have to take this times 10 to the negative 1 power. Remember, we move the decimal this way, we create negative exponents. When we move it this way, we create positive ones. All right, and now we have 1.35 times 10 to the negative 1 power divided by 1.0922 times 10 to the negative 2 power. We're going to be taking 1.35 and dividing it by, which is multiplying it to, excuse me, no, I'm sorry, dividing it by 1.0922. That's going to give us 1.236. And then remember, we have to take the bigger negative exponent and move it up. When we do this, remember, we're adding 2 here, which means we add 2 here. Sorry about that. Once again, a little bit of extra silliness from our program here. Now we have 2 minus 1, and that's going to give us to the first power, right? So anything to the first power is going to be 10. So that means we're moving the decimal 1 place back, right, to get rid of that, right? To get rid of that 1 power, we're going to move it that way because we're multiplying by 10. The exponent comes over 1. And that's where we get 12.36. So the thickness of a dime is about 12.4 because we're going to round up since 6 is bigger than 5. I'm trying to find my red dot here. Oh, there it is. Since 6 is bigger than 5, we're going to round up our 3 to 4. That's where they got 12.4. All right, let's move on. 30 is for you to do. 31 says concept skills and problem solving. The mass of carbon atom is 1.994 times 10 to the negative 3 power, or excuse me, yes, to the negative 23 power grams. The mass of Earth is about 5.9763 times 10 to the 24th kilogram. Determine how many times greater the mass of Earth is compared to the mass of carbon atom. Justify your answer. Well, it's about 3 times 1,050 times greater. First, we got to convert the mass of Earth to grams, okay? And the mass of Earth is then, remember, it's 5.9736, and we're going to multiply this, okay, to grams, 1,027 grams, all right? Then we're going to divide the mass of Earth by the mass of carbon dioxide. When we do this, we're taking that 5.9763 times 10 to the 27. I'm sorry, this is a misprint here. I just made sense of it. This is not, put here, this is not 27. This is actually to the 27th power. Okay, you might have remembered it. Let's see. You might have seen that over here when you had to the 27th. We're having to take this power now and meet up with the kilograms to grams. I feel I want to better give you guys a better understanding of why we got that exponent to be 27. So let me see if I can better illustrate that. All right, so we start with 5.9736. And remember, this is originally 10 to the 24th. Now remember, kilograms to grams, because we're going from, right, because they're asking us about the comparison here. We're going to say that 1 kilogram, and remember, this is in kilograms, all right? I'll put the kg here. 1 kilogram is going to be equal to 1,000 grams. all right? We have to put it to grams since grams is smaller. When we're comparing these grams up here, all right, we have to compare it to grams, not kilograms. So this is over 1, right? Which means I can cross off kilograms on the top and bottom. But now I have 3 more zeros to add on to this. So this is going to be 5. Let's see. This is going to be 5. And since it's going to be moved over 3 places, this would be 5 of what? Sorry. There we go. This would be 5, 9, 7, 3, 6. The decimal is now going to be 1, 2, 3 there, right? Since we multiplied it to 1,000, right? And now this was times 10 to the 24. To turn it to grams, remember we got rid of this. We're going to have to bring it back 1, 2, 3, which means we're going to have to go back. We'll bring it back. We make this bigger, right? So this is going to be 5.9736 times 10 to the 27th power. All right, that's where they got this number here. And then they use this number up here, right, the mass of carbon atom, to represent the bottom of the fraction. Now remember, we got a negative number here, right? So we have to add 23, which means we will add 23 up here. 27 and 23 make 50. And now we have 5.9736, and it's going to be divided by 1.994. That's going to give us 3. So that's how we got this answer. Whew, that was complicated. All right, let's move on. All right, there we go. All right, 32 is for you to do. Looks like I gave you a little lead there. 33 is for me to do. Human heart pumps about 7 times 10 to the negative 2 liters of blood per heartbeat. The average human heartbeat is about 72 times per minute. How many liters of blood does the heart pump in 1 year? And then in 70 years, wow. So in 1 year, we'll do that one first. We're taking 72 beats over 1 minute. We know that there's 60 minutes in an hour, 24 hours in a day. Remember, we're trying to find out, since we know how much it does per heartbeat, and we know how much it is per minute, we're talking about years and days. Now we're going to have to take 365 days in a year. Remember, we're crossing all the units of measure that are the same on the top and bottom out. So the minutes is going to be removed. The hours is going to be removed. The days are going to be removed. Now I multiply all these numbers together, okay? And that's what gives me this big number right here. And 1 times 1 times 1 means we have 1 year left over. Now that I got this big number for multiplying these 4 numbers together, I realize that this is going to be in scientific notation, 3.78432 times 10 to the 7th power. Okay, now we got the average heart beat about 72 times a minute, right? And we have the heart pumps about 7.10 to the negative 2 liters per heartbeat. So we have to take this, that heartbeat, right? How much it is per minute, or per heartbeat, and multiply it to how much it beats in a year, right? Because for every one of these beats, we're multiplying this to it. This is going to give us 7 times 3.78432. It's also going to give us negative 2 times 7, which gives it going to give us 5, right? And that's how they got 26.49024 times 10 to the fifth, because 7 minus 2 is 5. Now we've got to move this decimal back over here. And when we do that, that's going to be adding one more exponent. So that's going to turn it to 6. And that's how we got 2.64924 times 10 to the 6 liters per year. All right. Now let's find out how much 70 years. Well, we're going to take this and multiply it to 70 years, right? We do this, this is going to be, we're taking this and multiplying it to 7 times 10 to the first, right? Because we're moving it back 1. That's going to make a bigger exponent. When we do this, we have 7 times 2.649024, and that's going to give us 18.543168. And when we take 10 to the 6th power times 10 to the 1st power, it gives us 10 to the 7th power. Now, we realize we have to move the exponent over again because it is not in the right spot. And we do that, that makes our exponent even bigger. So that's how they got 1.854316 times 10 to the 8th power. So in 70 years, the heartbeat pumps about 1.85 times 10 to the 8th power liters of blood. All right, looks like the rest of yours to do. I will see you in the class and we'll grade it. Have a great